Your slides. Yeah, a bunch of Etherpad and all of that. It's right at 9:30, so yeah. I think. Yeah, I think you're good. So, yeah, I got because it seemed like with the doors out there, everybody was on their way places. So, yeah.
All right. Good morning, everyone.
Good morning, David.
That was very good.
Yeah. It's time to get excited about service discovery.
Yeah.
Woo.
Hi, how are you? My working group.
All right. Welcome to DNS Service Discovery at IETF 102. My name is David Skenazy. Our chairs are Tim Chone and myself. Tim Chone couldn't make it this time, so Tim Winsinski is deputizing for him. Thanks, Tim. First and foremost, the note well, given that it's Thursday morning, you probably have seen it by now. If you have not, please take the time to look it up and read it. It impacts anything you say can have patent consequences, so please read this if you haven't already. Other reminders that you should probably know as well. Anytime you come and speak at the mic, please state your name clearly. And please review other people's documents. What helps the IETF move forward is people reviewing documents and providing useful input. There is no barrier, there's no small comment, no bad question. Please read the documents and tell us, even if it's just to tell us that they're perfectly fine and you found nothing wrong with them, that's very valuable input. So Tim Chone, our co-chair, is stepping down. So I first would like to thank him for his years of service because he's done an amazing job. Could I have a round of applause for Tim Chone, please? What that also means is that we will like to find a replacement. So if you are interested, please contact Terry. Terry, can you wave at the room, please? That's Terry. He's our AD. Yep. So thanks to Barbara Stark, our minute taker, and Tim Wattenberg, our jabber. The minutes are on Etherpad. After you've said something at the mic, it might be worth it to come and check that everything looked just right. These are the links for our working group materials, for everything that's going on. And a quick view of our document status. We have quite a few documents going on in the working group. We'll actually go into more detail in all of them, and it'll be in a bigger font, which will make it easier for everyone. So what are we trying to do today? We're going to start off by reviewing the status of the almost completed open drafts for Discovery Proxy, DNS Push, and also DNS Session Signaling, which is in the DNS Op working group. We're going to go into the MDNS Relay and Service Registration. We're going to drill down a bit more on the partnership we have with Core and how we can interact with how they do service discovery. We're going to spend a little time on how the new drafts, kind of all the pieces fit together. And we're going to have a good part of the session on DNSSD privacy, where our main goal is to reach consensus on what the requirements are so people can start developing solutions. So this is our agenda. Would anyone like to bash the agenda? All right. Actually, before we get started, would anyone who was at the hackathon like to say a few words about what happened there?
I can't speak for everything that happened at the hackathon. It's Ted Lemon. But what happened at our table was that we had a bunch of work happen on implementing a DNSSD service registration protocol client or service, depending on what we decide to call that. So Tim Wattenberg did that work.
Right next to you.
Hi. Oh, maybe Tim could talk about it. But I'll talk about it first, and then you can talk about it second. So Tim did a great job, and we got a lot of good feedback on the service registration protocol document as a result of that, which has been ongoing all week. So the hackathon was a really effective way of stimulating some discussion.
Thanks.
Yes, Tim Wattenberg. Actually, this is my second IETF and first time at the hackathon, and I came there knowing basically nothing. So yeah, Stuart and Ted guided me through the draft, and by the end of the weekend, we had something working, which was we were able to see like actually working. And for the rest of the week, I continued to working at the server side. So maybe you'll have some running code there also in the next weeks.
Awesome. Congratulations, guys. This is really great to see running code at this point in the process.
By the way, Tom was also hacking on something. I don't know actually what he was hacking on. So do you want to on the registration server? Oh, cool. Do you want to say something about that? Okay. He was hacking on the server side.
Awesome.
Stuart?
Thank you, David. This will be a quick document status update. Terry has a question already. So we've got 3 documents here. I'll go through this quickly because I expect everybody in the room knows about these 3. We have the discovery proxy, which depends on push notifications, which depends on DNS stateful operations. So I will go through those in reverse order. DSO was updated in May, went through AD review. They started last call in June. That just completed a couple of weeks ago. Tom submitted draft 11 in July, and that is on the agenda for the IESG telechat next month. Push notifications were submitted last year. We did working group last call, and that was being in a holding pattern, waiting to see how DSO stabilized, because there were changes in DSO. One of the changes I think I remember was we removed the requirement that every request automatically has a mandatory reply, even when the reply doesn't carry any useful information, and that simplified the push notifications. So once we get the outcome of the IESG telechat, I propose that we ask for an IETF last call on this. We should probably review it within the working group to make sure we're all happy with where it ended up. Discovery proxy has been through working group last call. It's been through IETF last call, and that likewise was waiting to see how push and DSO stabilize. So once we get the green light from the ISG, I propose that we ask for publication of this too.
Hybrid. We're sitting in my queue.
State your name, Terry.
I'm sorry, Terry Manderson, responsible AD. Hybrid was sitting in my queue. I was waiting, obviously, on a whole heap of other things. Following a discussion that I had with Stuart yesterday, about 35 minutes ago, I approved that document.
Thank you.
Excellent.
So that's the status update.
Two comments on that. The telechat is August 2nd, so it's right at the beginning of the month.
Right.
So it's going to happen. Also, it turns out I did the Shepherd write-up for DNS Push. So I'm kind of glad we're actually going to review it, because that'll allow me to sort of review my which I wrote, I think, like 6 months ago. So I want to make sure that everything's sort of current as well. So, and I can sign up to do one of the other Shepherd write-ups. We can toss a coin over which one. So with the chair. So thanks.
Tom Pusateri, I think the push draft does need some minor edits to make it work better with DSO. So that's on our to-do list.
Yes, speaking for myself, in the next couple of weeks, my plan is to reread all of these in their entirety, because sometimes when you come back to a document after a bit of a break and read it with a fresh eye, you see inconsistencies or ambiguities in it. So, and I request input from anybody else who feels inspired to do the same.
Thanks, Stuart.
Ted?
Okay, so I'm here to talk to you about DNSSD discovery, or DNS, well, it really is DNSSD discovery relay. This document was adopted in beginning of the year. We finally actually submitted a -00 in May. Since then, I've been doing an implementation using Apple's open source MDMS responder stuff. And that was really fruitful in terms of finding things to fix both in the relay discovery relay draft and also in the DSO draft. Some of the stuff that Stuart was just talking about actually came out of that as well. This is actually, I have code working right now. The code is not a full-blown discovery proxy using the relay. It's just essentially a client of the relay that's doing DNS discovery over the relay. So I've been able to find my printer in the Apple UI while traveling, which has been really cool. Not that I've printed to it, but it's neat. That's not really particularly my goal in working on this stuff. My goal in working on this stuff is to create the technology that allows us to do discovery relay on, for example, a corporate network where you would like to have your brains in the center and as little brain as possible on the edge. So the document's pretty solid, and it's in last call. The big changes that we've done to the document, previously we assumed that link configuration stuff would be out of band, and it turned out when I was implementing the code that was really not fun. So I added support for in-band signaling of links. So that means that when a relay discovers that a link is present, you can subscribe as the client of the relay. You can subscribe to notifications to see that the link has appeared. When the link disappears, you can see those. The main application of this is that when you first connect to it and subscribe, it tells you that all of the links that it knows about right now just appeared. So you get a complete list of all the links that are available, and that just made the implementation of the relay client a lot easier. It's useful for debugging, and I think it's also useful for sort of the ad hoc network case. And then the provisioning vocabulary, there was a whole section at the end. This document, when I started out, had this giant section on how to provision it. That's gotten simpler and more clear over time, and at this point it's actually quite clear, I think, although comments solicited. And that's a result of the recent changes. Security considerations, we updated that to talk about crypto algorithm lifetimes. One of the issues with crypto algorithm lifetimes on something like this is what we're trying to do is create something that will sit in a device that you buy. It'll be on a rack in your network closet somewhere. And hopefully it'll be sitting there for a while because you don't want to just chuck these devices every 5 years. And what that means is that you may have some software on there that is not running the very latest crypto algorithms. So your TLS connection, the connections between the relay and the client are protected using TLS. Your TLS connection might be using not the most recent crypto algorithms, and you still probably are better off using that than not. So we also took out layer 2 source address reporting. I had put in layer 2 source address reporting, so when an MDNS message comes from the relay to the discovery proxy or the relay client, it includes the IP address that sent it, and it was supposed to include the layer 2 source address that sent it. Of course, implementing that is actually hard, and we weren't able to actually articulate a reason why we needed it, and since we weren't able to articulate a reason why we needed it, we decided to take it out. That doesn't mean that that was the right move. So if anybody's listening to this and thinking, oh my God, this is terrible, we really want the layer 2 source address, you should object. Please object. But otherwise, it's gone.
Stuart Cheshire, I'll say a couple of words on that because it was me that advocated for taking that out. It was in the draft as optional, and I don't like optional things in specifications. It should either be mandatory or not there. Making it mandatory was tricky because not all platforms let you get access to the MAC addresses. And I also felt it wasn't portable, that when you're tunneling these multicast DNS packets over TCP, the link layer technology at the other end might not be Ethernet. One of the things I'm working on right now for home automation stuff is Thread, which is an industry consortium using 802.15.4 radios. And there may be other technologies as well. And then the final point is that the current multicast DNS code on Apple products, and as far as I know, other things like Avahi, don't really care about the MAC address. So when I put it all together, I was thinking, why do we have this optional thing that the client doesn't even use? But as Ted says, we're discussing this because we want to get feedback from other people who might disagree.
Thank you. So status of implementation. So as I said, I've been working on an implementation. Everything is working except the TLS bit. And the TLS bit isn't working because I cared more about getting the basic stuff going. However, there is a certain amount of funkiness to the way that TLS is specified in this document. So doing the TLS implementation is actually pretty important. Also, I'm the only one that I know of who's implemented this, unless Tim, have you done anything on this? On the relay? No. Okay. Sorry, Tom. Tim and Tom are sitting next to each other. So it would be great to have a second implementation of this, just so that we can make sure that I haven't, that I don't have any blind spots that are represented in the code. And as I said, the current implementation is just MDNS responder. It's not the discovery proxy. So that means that we don't actually have a discovery proxy using the relay right now. The code that I'm working on is an MDNS responder, which is an open source project supported by Apple. Releasing code is slow, but we're working on it. And so that will be out at some point. I can't tell you exactly when because I don't know. And if you are interested in doing interoperability testing on this stuff, one of the fun things about it is that interoperability testing over the internet is very doable. In fact, I've done a lot of my testing using my home network while I've been away. So if you want to do interop with me, get in touch. Let's see. So documents and last call, please review the document. I'm going to keep hacking on the discovery proxy code and the TLS code. Whether we should actually request publication before those things are done is an open question. My intention is those things will be done quite soon. So I wouldn't mind holding off a little bit on that just in case. But I don't really anticipate any problems coming up. So I kind of leave that up to the working group, what you all think we should do there.
One comment, I noticed it's in working group last call, but there's been no comments on the mailing list. So I will scold you because I'm not really your chair. I can do that and get away with it. So, and also I just signed up to shepherd this. Dave and I just flipped for it. So I'll be reviewing it as well. So you're lucky guys, right?
Party
Yeah,
on.
so yes, please folks read it and sort of pass some comments to the list, plus or minus on working group last call.
Actually, could I have a show of hands for people in the room who have read a recent version of the draft? Thanks. So for people who haven't, it's not a very long draft. If you could take a look, that'd be helpful. And for those of you who have, could you please email the list saying, like, if you don't have any comments, say that you don't have any comments and you think it's fine. That's always helpful. Thank you.
Silence is not consent. It's the best way to say it.
Okay, so that's all I have on this one.
All right.
I think I'm next.
Oh, you're next. You're still.
He stays in
Yeah.
the big box.
Take it and give it back to you. Okay.
Well, we could do that if you want.
Yeah.
It's protocol. Okay, so the next document, this is a slightly longer presentation because we actually had a lot of churn on this document in the last 2 weeks. So the document was expired. We had been prioritizing working on the relay document and the relay implementation, but we really wanted to get it going for this IETF, and so I got a bee in my bonnet and did a pretty major update of the document right before the deadline. So that was posted prior to the IETF, and that's the one that if you haven't been following the mailing list, that's probably the one that you read. There was a ton of discussion on the mailing list following publication of the -01. As a result of that publication, I posted a second update, which had really pretty significant changes when the embargo ended. Oh, this is the old version of the slides.
What? How?
Yep.
Excellent. Yeah. So right. So Tim Bottenberg did a service implementation, and so we posted -02 on Monday. Following that, there was a ton of discussion. I've actually been up late 2 nights in a row, updating the GitHub version of the document to track the discussion because I do not want to lose all of the discussion that we've had. It's been really valuable. Thank you all for doing that. So the call for adoption is underway. I think the working group is really already working on this document, but that's fine. Hopefully we can adopt it. I think that the evidence of all of the churn that's been going on is evidence that the working group wants to work on this, but if you object, this would be a good time to say so. I think the document's actually been really thoroughly reviewed. If it weren't for the fact that we hadn't adopted it yet, I'd say it was ready for publication. Be that as it may, there are still things to talk about, so let's talk about them. What the document does is provide a lightweight way of registering services in the actual DNS as opposed to MDNS. It provides a way of authenticating updates so that if you have successfully published a name, somebody else can't come along and override your publication of that name. This is cryptographically authenticated. It's first come, first serve, so it's not actually super secure, but it's secure in the sense that it's difficult to take over a service once it's been established. It provides garbage collection using the, we have a companion document, which I don't actually discuss in here, but it's draft SACAR EDNS 0 lease or something like that, and it's mentioned in the references to the document. And actually, we need to talk about that. I don't have it on the slides, but that document is required for this document to happen. So we should figure out whether that's something that we want to do here or whether it's something that ought to happen in, I don't know, DNSOP or someplace like that.
On this one?
So that's draft SACAR is documents the EDNS 0 update lease option, and the update lease option is required to say how long these updates last. So in other words, the standard DNS update, just you do the update and it's just in there forever. But for service registration, we want the update to expire after a while, because otherwise you're going to have a pile of garbage.
And it's an EDNS option, right?
It's an EDNS
So
option.
we can probably do it in, oh, I'm sorry. Yep. So we can probably do it in here because I believe the EDNS options go through an expert review anyway.
Yeah.
Yeah. So it'll be fine to do it in here. And at that point, we'll get the DNS op folks to comment on it without sort of dragging the whole working group through it.
Okay.
So
Cool.
unless Stuart wants to do something different.
Well, just a bit of trivia for Stuart Cheshire from Apple. We the lease update was put in, I think, 10 years ago when Apple used it for the Back to My Mac service. IANA assigned that option code. I think it's number 2. I think we have the first 2 EDNS 0 options, 1 and 2. So that's already recorded. So there's no problem there.
And implicit in that is that the expert review that you just mentioned, Tim, is not actually going to happen because it's already happened.
Then we don't have to,
So-
then it's less of an issue then.
Yeah.
Yeah, then it's less of an issue. Sorry. Sorry, Carrie.
So that in that case, especially given that Tim is chair of DNSOP, having that document here sounds reasonable, and we'll obviously reach out to the DNSOP list to make sure that everyone there gets a chance to review and comment on it.
Great. Gary?
Carrie Lynn, Oracle, and I am optimistic that this group may yet recharter and bring M2M service discovery into its wheelhouse. And Karsten may be able to speak to this more eloquently than I can, but there's discussion going on now in the core working group vis-a-vis the resource directory about how a device can actually assert the veracity of its claim that it provides a given service. And so rather than rush this, to finality, I wonder if there's any support in this group for investigating this question. Now, where I'm coming from is that in the DNS as we know it, there's always been a human in the loop who ensures, let's say, the veracity of the zone file. And then DNSSEC is all about making sure that the answers, the responses you're getting back to a query have not been screwed with along the way. But we're relying on the human in the first place to make sure that the records in the zone file are accurate. So this seems to me a related problem when we have a world where devices or microservices are doing discovery, that we need to ensure that somehow the things that get registered, correctly do what they say they do. So it's just, I guess, a
Right.
general question.
So you're talking about the enrollment problem.
Yeah.
And I agree that's an issue. The document actually specifically mentions that you might have some kind of enrollment process. It doesn't state what the enrollment process is. I think that the public keys that we use here would be the sort of thing that you would probably use in that enrollment process. So I think we're okay with this bit here. And I would definitely love to work on the enrollment problem. Because I think that it's applicable in environments like HomeNets also. So it's not just an IoT thing. And in fact, there's work that's happened on the enrollment problem elsewhere. Like I think Thread has an enrollment process, and I know that AMMA has an enrollment process. So there's there's stuff going on already that we could probably leverage. I'd hate to see us invent many enrollment processes, but we'll see. Andrew?
Andrew Sullivan. So I agree with you. I don't think that this working group should tackle that enrollment problem at all. And just sort of incidentally, it isn't true that there are humans involved in every DNS registration, right? That hasn't been true for many years. So I think you're right. I don't believe that should be in this document. I think you should say exactly what the document says. There is an enrollment. You may have an enrollment problem here, and that's none of our business how you do that. I think that's right.
Thank you. Okay, so just to continue a little bit on this, since we're talking about constrained devices, one of the things that we wanted in this as a feature is that a constrained device can send a single UDP packet that registers its service, and that would use Anycast. So basically, it doesn't have to go out and figure out who to send it to. It just creates the registration, sends it to the Anycast address, and on a constrained network that supports this, the Anycast would wind up at the registration server, and the registration would happen, and a response would come back, either that the registration succeeded or that it failed. And then less constrained devices would just do service discovery to find where to send the update. So that's equivalent to what we're doing right now. Stuart, I don't know if you've actually seen the latest conversation that we had about this, but the version of the document that we had before was saying that we would use DNSSD-update or DNS-update ._UDP, but we're actually requiring TCP, and there isn't a registration for TCP. And so the latest update that I made to the document actually adds an IANA section that registers this name instead, DNSSD-SRP with _TCP, so that we have that taken care of. And we talked about whether we wanted to have a specific registration for this. I think it's useful to have, but we can discuss that. There are a lot of issues that I'm going to go through quickly. If these ring a bell for you, please discuss. If not, it's, we've had pretty good discussion on this. So one of the things about this protocol is that it's essentially using RFC 2136 DNS update, but it has some custom semantics. The reason it has custom semantics is because we're allowing unauthenticated devices to register themselves in the DNS here. And we would like to make sure that we don't allow arbitrary registrations. We want service registrations. And so when a DNS update comes that's conformant to the service registration protocol, then we're essentially saying that update you can process, but if the update isn't conformant to the service registration protocol, then whatever other rules you have about authenticating updates are the rules you should follow. So, the issue with that is that the semantics are more complicated than any other update semantics that currently exist. Like current update semantics are things like you're on the local wire, or you have this key, or there's one that allows you to do an update if you have a particular SIG0 key that is also in the update, and there's another one I think that uses TCP or something. So there are a number of different ways that you can, that for example, bind9 will allow you to authenticate updates, which I suspect exist in other servers that I don't know about. This is a much heavier piece of semantics. And so either we need a shim or we need the authoritative DNS server to have some pretty hairy semantics in it. Pretty hairy just means like, there's some consistency checking between the records and the updates. So it's not like it's insane or anything, but it's definitely, there's a section in the document that explains exactly what these constraints are. I don't think there's a way around this, so I think that we just have to accept that this is how it's going to be.
Stuart Cheshire again. The comment I'll add to this for the people in the room who've not been following the discussion closely is with normal DNS update, and you can use the NSUpdate command, the assumption is that if you have the key, then you're trusted to make sane updates. What we want to do here is allow you to buy some product and plug it into the network, and without any prior trust credentials, trust it to do some updates. And once it's done the update, it also puts a key record into the DNS database that it can use to authenticate subsequent updates. So that's how it claims ownership of the name, and nobody else can come in and steal it later. So if we're going to allow this untrusted device to do updates, we need some kind of sanity check around it. What I've been thinking about this is I think it would be good if we design this so that the update that a device generates is a perfectly valid DNS update that would work with a normal DNS update server. So you can take bind9 or your favorite server, turn on DNS update, and these devices will register. What bind9 won't do today is do the sanity checking that what they're registering makes sense. So guarding against malicious or buggy clients becomes a feature on top of that, but basic functionality, and in fact, that's what Tim did at the hackathon. He was just using standard bind9 and doing updates, and as long as his updates were well formed, then it did the right thing, but the server was not enforcing that.
Yep. Yeah. Just to add a little bit to that, that was a great way of introducing or explaining that. One of the things that we don't have in these updates is update constraints. And the reason we don't have update constraints is because the way update constraints are normally implemented is you try one thing, see if it works, and then if it doesn't, then you try the next thing. So in other words, you do multiple updates, and we were trying to keep this down to a single update if possible. And in order to do that, we basically put the burden of imposing constraints on the server. So if you're updating a regular RFC 2136 server, then you would need to do something a little different than what you're doing on an SRP capable server. So another thing, so one of the things, so normally with DNSSD updates, what you do is you go out and you look for dr._DNSSD.domain, and you use that to figure out what domain to send your registration, or what domain to register your service in. And the problem with that is that that's a lookup. And so that's, if you're on a constrained device, doing a lookup is, more packets that you're sending and shorter battery life. So in order to work around that, we propose that constrained devices send their updates to services.arpa, which will be special use domain name. And then the registration server will rewrite that into the local default registration domain, whatever that happens to be. And that just seems like really the only way to solve that problem, and I think it's pretty easy to do, so I don't think it's bad. Obviously, if somebody here thinks it's bad, you should let us know. And then that brings up a second issue, which is that since we want all of these updates to go in a single packet, if there were a PTR update, or sorry, a reverse zone name update, I'm realizing as I'm saying this that actually this is not important anymore because we decided we weren't having the client do the reverse zone update. If the reverse zone update happens, it's the server that does it. So I guess I can actually skip the rest of this slide, and I will for the sake of time, but know that we considered that. So we don't support the ability to do queries that will allow you to connect to something that's on the other side of a NAT. So if you register a service that uses an IPv4 address, then it will only be reachable if it's global or if you're within the same RFC 1918 routing domain. So I think this is okay. If it's not okay, we could talk about how to work around it. In fact, there's a later slide that talks about the really badass registration server that I mentioned here. Another issue is A record and quad A record security. Do we want to enforce that the client can only update its own A record? So in other words, if the update comes from an IPv4 address and it updates an A record, the A record has to contain the IPv4 address that the update came from, and similarly for an IPv6 address. If we want to do that, that means that there's going to be a lot of updates for a client that's dual stack or that has multiple IPv6 addresses. And I don't know if we actually came to a conclusion on this. Tom?
It seems like you would have to do that over a TCP. You couldn't do that over UDP.
Well, so yeah, you can't validate reachability without doing TCP. But on the other hand, depending on like if this is on a constrained network, you may have some other way to validate that the question or the update actually came from the IP address that it says it came from. So yeah, there has to be, in order for this to be at all useful, there has to be a way to validate the source address. We have that for if we're doing TCP registrations, but we don't have that if we're doing UDP registrations necessarily. So I don't think we actually came to a conclusion on this. This is something we need to decide.
Oh, you just woke me up. It's okay.
if you've already got key records associated
Name,
with it,
please.
Mark Andrews, sorry. If you've already got key records there, they associate the name. It really doesn't, IP addresses, you got name to IP address mappings. It doesn't matter. You can put any address in there. It doesn't matter. The service will work or it won't work.
Mark, remember that we're doing ad hoc registrations
Yeah,
here, so we don't actually have a secure proof of connection between the IP address and the.
We're registering something like my printer X. If you put garbage in there,
then your printer won't be reachable.
your
But you can use
printer
this-
won't be reachable.
But you could use this as a way to create a wedge to get to a service on the network that's not reachable from outside, for example. So you could create a DNS entry for a device that you want to be able to attack from a host that's able to reach it.
You can attack it anyway. This is not going to. You're not going to protect anything.
I don't want to get too deeply into this, but there are actually mechanisms for comparing sources in HTTP, and so if it's an HTTP port that's listening, there's actually this could potentially be used to get access to the user interface of some device on the local network by an attacker off the local network, and so that's a reason that I would suggest that we'd actually like to not allow updates to A or Quad A records if they don't come from the address being updated. That's my reasoning. I'm not convinced that that's a good enough reason, but we should seriously think about that and not just say, oh, it's not a problem.
I don't think what you're trying to achieve is achievable.
Perfection, at best is the enemy of good enough. So yeah, it's not. We can't make this perfectly secure, but we can certainly make it harder to do an attack of that sort.
Stuart Cheshire, I think I agree with Mark Andrews, although maybe for slightly different reasons. I think the simplicity of packing everything into one update is useful for constrained devices, and we need to weigh that up against an analysis of what the threat is if some rogue device creates address records that point at something else. Mm-hmm. And right now in my head, I'm not clear on what that downside would be. It sounds like you are, so maybe we can.
Yeah, as I think about it, I'm not sure that it's possible to do that attack. I would just like to eliminate the possibility that we can do that attack before deciding that we don't care about it.
David Skenazy, chair hat off. I think I really agree with Ted here. If it's cheap to protect against something, we should protect against it, because the fact that we haven't thought of an attack doesn't mean it doesn't exist. And I do agree that in some cases this might be too expensive, like very small constrained devices, but those don't need to advertise 4 addresses. They just use the one and they're done. Yeah, I mean, any device that's implementing, any device that's implementing LowPan or something like that is going to have a single IPv6 address. It's not going to need to register multiple IPv6 addresses, and hence, I don't think we actually have a problem for constrained devices. Okay, so right now the document only lets you update DNSSD records. It's very restrictive about what constitutes a registration. Service names, you can only update the PTR record. You can't delete a PTR record. We'll talk about we might relax that, but this is what it says now. Service instance name, you can only add an SRV or a TXT record. The forward mapping, that is to say I think the name that we're using now is the host information mapping. Can only have an A or a Quad A plus a key record. Was there one other record that you thought it needed to be able to have, Stuart? Okay. So, and then if there's a reverse mapping, then it can only have a PTR record.
Now, there's actually, since I made this slide, I didn't correct this on this slide because I didn't notice it. The service instance name actually also has to have a key record on it. And the reason for that, I'll get to. Actually, I don't know if I talk about this, but in first come first served naming, we have the ability to add a record, to have a record that just has a key, have a name that just has a key record on it, and that holds the name, prevents somebody else from claiming that name, but there's no service advertisement on that name. Therefore, a service like if you have a printer that's not on all the time, some other device can't come along and claim to be that printer and take over that printer's registration, but the printer doesn't appear in the list of printers that you can print to when it's not turned on. So, all right. So basically, there are consistency checks. The service name has to be pointing to a service instance name that's in the same update. So if you're going to add a service name, if you're going to add a record to a service name, then it has to be a record that is referencing something that's also in the update. A service instance name has to point to a forward mapping. If there's a reverse mapping, it has to point to a forward mapping, but now we're just having the server do the reverse mappings if it wants to. So the benefit of this is that the updates are consistent. The disadvantage is that we don't allow random updates. And maybe the limitation on flexibility could be relaxed somewhat. I don't know of a use case for that. We talked about just having a simple host name that doesn't have any service registrations. I think that might make sense. But I can't think of any other reasons for doing this right now. So if anybody is aware of a use case that we're excluding that we shouldn't exclude, it would be good to comment on that. Toko was talking about wanting to be able to have his name service be off-link or off network. So in other words, he would do his service registration to an authoritative server that's sitting in the cloud somewhere. And that authoritative server presumably would actually only be reachable from within the home network, because otherwise you're publishing RFC 1918 addresses and ULAs in an authoritative name server that's reachable elsewhere. So in order to do that, IP source address validation probably doesn't work end-to-end, although we've actually, part of my problem with this presentation is I did this presentation and then we did a tremendous amount of work on the draft, and so some of these issues have actually been somewhat addressed, and I'm thinking maybe this issue has been addressed. I talked about having a shim to implement the registration service, so the thing that receives updates being a shim rather than a stateful authoritative name server, and I think that solves this problem. So I don't think we need to talk about this one. One thing that's interesting about publishing names publicly is that if we wanted to publish a name publicly, then, and it's a name that's pointing to an RFC 1918 address, then we would need to use something like PCP to enable devices to reach it. But we could also just use IPv6. So when I say we could also just use IPv6, I mean, there is a bit of an issue there. When I talk to people about using this in practice, a lot of them just don't have IPv6 yet. And so, you know, do we care about that? I mean, I don't know. It's something to think about. Backwards compatibility. So right now, as Stuart was saying, you can actually take a conforming service that's able to do a registration, and it can do a registration to a regular DNS authoritative server that accepts DNS updates that comply with RFC 2136, as long as it's configured to allow updates that aren't authenticated. So the document describes how to do that. I think that's useful. It also talks about, let's see, it also talks about if you have a service that's doing SRP and it realizes that it's got access to a DNS update server, but that DNS update server doesn't support SRP, which is pretty easy to detect, how it can safely do updates even though there isn't support for SRP. And if we consider that to be important and worth doing, we should probably make sure that we are happy with that section of the document and that it's clear. I'm not sure how important this is, so it's kind of up to the working group how much work you want to do on this. I'm happy to to think about it in more detail if it makes sense, or we could just take that out. Discovery proxy with service registration. Oh, right. So in the real world, we're probably going to have a lot of networks that have discovery proxies and also, I hope, support service registration. If that's the case, then discovery proxies, the way discovery proxies work is that each link has its own subdomain. And registration protocol, because we have first come, first served naming, we have a way to disambiguate names. There's no way to have a name clash with first come, first served naming. So therefore, we don't actually need to do this one subdomain per link thing. And in fact, it's hard to do. So right now, what I think the answer to that is that there's another subdomain that registrations go to. So does anybody disagree with that, Tom?
Yeah, so I think I addressed this morning, if you saw my note. There is, because you can't do the collision stuff that everyone sees, it's hidden. There's no way when you get back a response that says that name's already taken, you don't know what name to use next, to try next. So you could try incrementing by a number and trying again and again and again. If you've got 20 devices, you try 20 times. That doesn't seem good for battery life. Or you could try and generate some unique thing from the beginning, but now you've got a non sort of human readable name, which was the kind of the goal, I think, at one point.
Yeah.
So this is a problem, but it's not just a problem with your with the service registration protocol. It's a problem in general for doing unicast updates in the single namespace.
Yeah. So Stuart and I talked about this at some length about a year ago, and we actually don't know of any cases where this happens in the wild. And what I mean by that is that I think, both witnessed this happening, but when we've witnessed it happening, the reason we've witnessed it happening is because we've had MDNS bridges that join two MDNS domains in such a way that a device that's connected to both of them winds up fighting with itself. So that's why we think this is a really bad problem, because we've seen that happen a lot.
Yeah, well, the example in my note was that you're going to have these IoT devices that come configured with, some name, and you get 20 of them, and they're all going to be configured with the same name.
Right. So for those devices, I think that you're going to wind up having to figure out a way to, there's no way to avoid having the user have some kind of interaction where they say, okay, this is the light switch that's on the wall, on the south wall downstairs in the living room, right? That step there has to be some kind of enrollment step like that in order because otherwise you've just got a house full of light switches and like somehow you have to know what those light switches are. There's got to be a user interface where you're configuring all of this stuff. And if there's a user interface where you're configuring all of this stuff, then the only real question is whether the name change is actually a name change on the device, or whether it's a name change that the network remembers and the device doesn't know about.
Yeah. Well, if you get 20 of these things in, and it comes with an app on your phone, and you want to configure them, there's no way to ask the service, wherever you're registering to, the registration server, what all the ones are that are already there.
Sure.
So that it can figure out how to make unique names, or it can ensure that.
This is Dave Robin. On that, I think we're all used to, Alexa-ABCD. So use your MAC address, use whatever. It's not bad. If it's only 4 digits to make it, ambiguous or unambiguous, it's not a problem. You have 25 light bulbs, and they all say light bulb dash blah 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 blah. So you're right. They have to be paired somehow. The question is, how you mentioned, I think in your draft, the last one, I think I read it last night, that there's no delete me.
Right.
You just wait for garbage collection.
Yeah.
Right. Well, here's a use case where I think there needs to be a delete me. There's two use cases I wanted to bring up. One is this one exactly. It comes up as lightbulb ABCD. I give it a name of living room left side. I want lightbulb ABCD to go away.
Right.
Right. So that device needs to say, I'm changing my name, delete this, add this. So I think that's a real strong use case for not waiting for garbage collection, because it's going to just clutter the namespace for a day or two until it goes away.
Right.
The other issue that I was going to talk about earlier is replacement. I know I'm replacing this device on the wall. So I want to power it down and properly, not unplug it. But when I push this power down, or I push this format button, I push the format pin and I clear it, as it in its dying breath, it says to you, delete me. Now living room left side is gone. So the new device comes in and it claims living room left side.
So
otherwise you're going to have living room left side 1 for the rest of your life because you couldn't delete living room left side at the time you installed it.
Right. Yeah. So that's interesting. I don't think that the dying breath scenario is actually realistic. I think that even if the device could do that, what's going to wind up happening is that people are just going to unscrew the light bulb and chuck it. They're not going to go through that process. So
that's true. Well,
or it's already dead. Yeah.
Or it's already dead. Yeah. No, I'm coming from the commercial space where very often we have a device that is functioning, but you want to change it, upgrade it, whatever, and you do something to it to shut it down or to format it.
Yeah.
And in that case, we'd like to be able to delete that name, not wait 2 days to reclaim it.
Yep. Absolutely. Yeah.
So the alternative is to clone it with a USB stick. Here's your key, new guy. I mean, I'm thinking back here of ways to do this to where the new guy can come in and claim ownership using the old key from the old guy. And I don't like any of those scenarios.
Yeah. The other thing you could do is you could just go into the UI and say, I'm replacing light bulb living room left. And
the UI to what?
So right.
DNS,
So
that's
I'm assuming
I have some way of trustedly updating the DNS server.
Right. Well, I think
some other path.
In that scenario, I would hope that you would have a way to do that. But in a commercial building, you don't have a way to go in and say, delete that record.
Oh, no, the DNS server is owned by a different group.
To be clear, I'm not saying you're wrong and we shouldn't have the delete feature.
Yeah.
I'm kind of leaning in the direction you are right now. So I'm not saying no, I'm just saying that realistically, you probably also want that UI.
Right. Well, that delete message might be done on behalf of, I have a tool that's deleting it on behalf of it because I know the private key of the device because I commissioned it or I have a backdoor to it or somehow I can be that device after it's dead.
Yeah.
So
but you also have root on the name server. So.
Right.
Thank you, Dave. Those are some good comments. In fact, I think there's 3 things that we should make a note of. You're right about the deletion stuff. And in fact, using Apple's Back to My Mac thing, if you go into the sharing preferences and turn the service off, it does do a DNS update to delete those records. And I hadn't realized until now that we forgot to say anything about that in the document. So we should definitely add a paragraph or 2 about doing deletions. You talked about the DNS server. It's important to remember that this is using the DNS protocol. That doesn't mean it's run on your corporate DNS server, the same one that serves your website and your email.
Sure.
I mean, it could be in principle, but probably not in most cases. And then the third point, I think, I don't think we say anything about this in the draft right now, but I think a section talking about the user interface, because I think it's almost certain that any of these devices offering this service registration service will have some kind of web UI or something like that that lets you see an inventory of what do I have on my network, and there'll probably be a delete button next to each one of those things because you may have a device that just fails. Its key is inside that device. It's gone when the device fails. You didn't make a backup of it on a USB stick, and at that point, you don't want to wait 28 days for it to expire. I mean, if all else fails, I guess that's the backup, is you wait 28 days for it to expire, but having a quicker way to go and delete stuff, I think is important, and we should talk about that.
Yep.
Mark Andrews here. I do stuff like this with update all the time, where you have an administrative key
Yeah.
that can use update and can nuke anything, change anything.
Yep.
And you've also got the device keys, which are very specific. You can have the same, you can have policies tied to keys. And this is all about policy in the name server.
Yeah. So
This isn't this is a solved problem.
Yeah.
It's been solved for 2 decades.
Yeah.
We're going to cut the mic lines after Carrie.
Carrie Lynn. I just want to clarify my earlier remark about a human being in the loop. Even in the case of dynamic DNS, typically the human has delegated the authority to add records to, by setting up a security association or something like that. So that's what I just meant by, human in the loop. So here, obviously the problem is you take something out of the box, how do you trust it? And I'm just wondering if you've looked at, maybe weak forms of authentication. So for example, can we assume that, let's say it's a printer that's trying to register its service. Presumably it's already participating in MDNS, right? So is it on the link and defending that name already? And could the registration server make use of this fact to
how does that change the security?
Probably doesn't. It's a weak.
What we actually did here was try to replicate the security of MDNS in a network that's not a single link.
Yeah.
So I don't think that particular solution solves the problem. I think it's an interesting question, but again, as Andrew was saying, I think it's a separate problem. So I don't think we should muddy the waters here. I think that, for example, the document actually talks about, you could have a domain where devices you've never heard of get registered automatically, and then once you so you might have a little app on your phone that gets a notification, a new device came on the network. Now, you remember that you just plugged in a new device, and gosh, it's that device. So you say, okay, authorized, and then it automatically is put in the zone of things that can be discovered. But until then, it's not discoverable.
So just for my
So there are ways to solve this problem.
So just for my own information then, let me phrase this as a question. Is the device that's doing the registration also participating normally in MDNS? Could I?
Well, so that's in itself a good question. And I think, I don't know if we've really, Stuart and I have talked about this, and I think, Stuart, correct me if I'm wrong, your feeling is that it's better that it be doing both MDNS and?
Well, Dave pointed out that you have cut the mic line, but if you'd like, can I respond to this? So one aspect to this is I imagine new classes of devices and new network environments where we will only be doing the active registrations,
Right.
And we won't be doing multicast DNS at all. And the one case that I'm particularly thinking about right now is this thread group wireless mesh network. And on low power, low speed, short range wireless devices with battery power, yes, you can build a multicast distribution protocol that floods the multicast everywhere, and you can make that work, but it's not clear that you would want to. So if we're successful, what I imagine happening is that thread networks will only use service registration protocol. I could also imagine in things like building automation environments, even though you have Ethernet and you could be using multicast DNS, there may be whole classes of home automation products that just by the specification for that product, it doesn't do MDNS at all. So I think the area where you've got devices that do both, that will exist, but I'm imagining that'll be a fairly small overlap.
So, what a coincidence. I think we're near the end of the slide deck. Yeah, so it sounds like the answer to this question is yes, so I'll just go right on. Sharing names across devices, this is something that Tim brought up. So there might be some situation where you have several devices that all provide the same service, and they're really providing the same service, not different instances of the same service. And do we care about solving that problem? I can't actually think of a use case where that would happen. I'm sure there is one. Personally, I think the answer to that is just have a common key between devices that's shared. So, but I mentioned this, I don't think we should talk about it now because I think we're a little short on time, but think about that. If you think there's a use case here, send me some email, send mail to the mailing list, not just to me. So next steps, as I said earlier, despite being a call for adoption, I think this is actually pretty close to ready to publish. If you don't think that or are skeptical, then please review the document and send comments. I think that since we have all of this energy on the document right now, I'd like to move quickly on it. What do you guys think?
So I think this is good work, and I support adopting it with qualifications. The FCFS stuff is I think it's clever and it solves a real problem here. But I also think that 6763 already defines service registration protocol as dynamic DNS update. And so I think that this confuses things with that. And I think that if we would change the name of this, then I would fully support adoption. And I think a name something like a dynamic update protocol, a dynamic update profile for constrained services would be a better name for it, because it's really just a profile of dynamic update. It's not a new protocol. And that would prevent the confusion from what we have now, which is just our service registration protocol is DNS update.
So are you aware of people using DNS update for service registration now?
Are there instances of it? There's people doing it manually. Is there like products out there? Not that I'm aware of. But it is what 6763 says.
I don't think 6763 ever mentions SRP.
It says we don't need to define a service registration protocol because we already have one. It's called DNS update.
Yeah, I'm not really seeing an issue here.
Okay, can we take this question to the list, and also I'm cutting the mic lines after Mark.
I'll make this quick. Tim Wasinski, support adoption, send an email about it. I made one comment that you'll want to address the underscore adder leaf work that Dave Crocker's been doing, just to make sure that we're all covered. I don't think you guys cover it, but I think that's going to, because that stuff's moving through working group last call right now. So just, I made a note about that in my thing. That's it.
Thanks.
Mark Andrews, one thing to keep in mind is that update is processed on a per record basis. So if you want to do first use, make sure the key records are at the top of the update request.
Okay.
All right, thank you.
So from the interest on the list and in person, it sounds like there's interest in working on this in the working group. The adoption call goes until next week. If anyone thinks that this should not be adopted by the working group, please bring that to the list. Otherwise, we're probably going to be leaning towards adoption. Also, if you do support adoption, please say so. That would be helpful as well. Carrie, come on up.
I thought it was you earlier.
Good morning. I'm Kerry Lynn, and I am presenting a proposal for mapping between information in the core resource directory and DNSSD on behalf of my other co-authors. So first question that might occur is, why do we care about this? The first simple answer is that it's part of CORE's charter that they should interoperate with the DNS. I find myself in the interesting position of trying to convince the core people that they should care about DNS at all, and convincing the DNSSD folks that core resource directory is not going away anytime soon. So it helps to talk about a couple of use cases that I see. I'm sure there are many more, but in the case where we have where we assume that COAP clients will not be all pervasive anytime soon, and we want to support heterogeneous environments that make use of an edge device called a cross proxy that support HTTP clients and COAP servers, it may be more natural for the clients to be existing in a DNSSD kind of environment. I should pop up and say that there's kind of a meta question here. I'll talk a little bit about REST and core and that sort of thing, but primarily resource discovery is concerned with very fine-grained discovery about what resources exist in a core server, which is typically a web server or very much like a web server. I would say that some subset of resources can be considered services in that they are RESTful entry points. So that's kind of the starting point for this whole effort. I believe that DNSSD and resource directory can be complementary in the sense that you could do very coarse-grained discovery in large networks to find servers of interest, and then perhaps explore them or do introspection on them to see if there are the servers that you're interested in. And finally, it's obvious that DNS could be used as a bootstrapping mechanism to help you find resource directories in the first place. So just a little background on core. I did the corresponding presentation a few days ago where I just described DNSSD to the core folks. The main deliverable of the core working group is COAP. It's the application protocol that sits on top of all the 6 low data links. The basic paradigm is it supports REST over UDP, but now there are other bindings such as WebSockets, TLS, that sort of thing. If you're a REST adherent, then you know that REST really is a set of architectural constraints. The basic operations are create, read, update, delete, and notify. Crucially, COAP does support notify in that it supports, sort of an observe pattern. So you can be notified of changes in the resource, and this provides for kind of a weak consistency of state throughout a distributed system. All the transactions between the client and server are stateless. Everything is a resource, as I said. It's identified by URI and other metadata such as content type. And when we talk about, say, a RESTful entry point for an API, typically you'll have a link that gets you to that API, and then you can explore the other degrees of freedom, the other things that you can access in that API through other links that are provided to you, where a link is essentially a URI plus metadata. So core resource discovery is based on web linking. There is a sort of a foundational RFC 8288 on which the core web linking is based. As I said, a link is basically a URI plus other metadata attributes. Crucially, it typically involves a link relation to tell you what you will get when you follow that link. So it's identified by a piece of metadata. And for M2M transactions, the link relations are pretty much all you have for driving state in the system. It's implemented by doing a get to a well-known URI, and what you get back is a set of links that tell you what that server supports. So what we're proposing is that in the case where you have a core device that wants to export information to the RD, we will add a new resource that provides hints for some mechanical translation or mechanical export. So currently defined attributes in 6690 include the resource type, the IF attribute, which is typically a URI to some sort of formal description like a waddle or a hyperschema, the size of the thing. And we're proposing some new target attributes in our proposal. So EXP is right now defined as a binary that would indicate that we want to export this data. Instance name, as we define it in our, as it's defined currently in the proposal, is much like the instance in the service instance, the instance portion of the service instance name in DNSSD, except that now, talking to other folks in core, that wasn't the original design of INS. So we may have to do some things to make that unique in the namespace, the DNSSD namespace. will take resource type and somehow translate that into service type. And we feel that having the IF is important because that provides you information about the API. So this is the rough proposal for how to do this translation. The INS resource will provide at least a foundation for the instance part of the service instance name. It may be that we also ultimately include this other piece of metadata, which is called the endpoint name, and somehow, munge those two things together to create a unique instance for DNSSD. Similarly, the resource type is converted somehow into a unique service type. I should just make a side point here that while DNSSD provides for pretty strict limits on things like the length of a label and the alphabet that can be used, the format, it doesn't seem like web linking in core actually provides for such constraints, and it seems to be an SDO by SDO decision as to whether they're going to limit the lengths of these things and which character sets they can use. So we'll have to go from a less constrained environment to a more constrained environment when we do these conversions. So one of the TBDs is how do you figure out which domain in which to locate the devices? Stuart and I have talked about this. There's actually a reference in the draft to section 11 of 6763, where, for example, it says you could discover, which domain you're currently in on your link and put the records there. So it's essentially could be a local matter, or we could take some additional steps to constrain that. So this is just a color-coded example to show how you start with a mechanical translator could start with a query to the core system, and it could basically search for servers that have this EXP attribute set to true, and it might, for example, get back a response from a device with this address that says that it supports a temperature sensor at this path, the resource type is this, the instance is set to this, and you could find some information on the interface description here. And the resulting RRs would look something like this. Any place where you see an ellipsis, just replace that with example.com dot. I just omitted that for brevity. But basically, if you follow the colors, and you're not colorblind, I hope, you can see how these translations occur. One thing I'd like to point out here is when we're building the service instance name, there's sort of two ways we could go about it. Assuming that we start with resource type as the base, we could either sort of have a flat service type for each resource type, or we could do it in a hierarchical fashion where we basically have kind of a base organization that's responsible for creating its own types of labels and do this in a hierarchical fashion. I should say that, for example, Broadband Forum, I believe, has done something along these lines, and where they've got, say, multiple different bindings, WebSockets, TCP, UDP, they actually use this label to express more information about the protocol stack, and this part to describe the actual service that's being exposed. So that's basically the idea.
Dave Feeler. So first I'll just summarize the issue that was brought up in the core one, and then I'll offer maybe an idea that to augment that, since what I've been thinking about. So the issue that we talked about in core is coming up with the _OIC dot label is really hard in some cases. The RT value on the top could be a string like OIC.R.temperature, or it could be any URI. And so when you have that flexibility, then it's really difficult to come up with the _OIC. So that was the discussion. We said there's an issue to be discussed. We said take it to the list. I started a list discussion and so on. So what I'm thinking about now as you're presenting this is there any value in having per organization _OIC dot, or should we just define an resource directory dot and just lump everything into the part where you have r-temperature, where you have a lot more flexibility that's there.
So.
Because you don't need IANA registration, you could do, hashes or whatever else to deal with lengths and encoding, and you wouldn't need to worry about how do I map it to this thing that has to be IANA registered that's underscore OIC. If you just define one, you said everything fits into there if it's coming through this conversion.
Sure.
That's my
So
question.
to take your points one at a time.
That we did not talk about yesterday, so that's why I'm asking it now.
To take your points one at a time. The first is that 6690 was actually the first output of the core working group. And so that definition for resource type, which includes any arbitrary URI as a value, was basically specified before there was any operational experience with COAP at all. And so I've actually talked to a few people. Nobody knows of anyone who's using it in that way. I would propose that, there was actually also some discussion that's in the core working group that said now might be a good time to sort of tighten up the definition of some of these, metadata, the values of some of these metadata attributes. And so, we certainly have no shortage of attribute names. We could define an RTI if you need an arbitrary URI, and we also have the IF attribute that could take an arbitrary URI that describes, the resource as well. So, I don't know. In the general case, perhaps it's up to anybody who wishes to export this information to figure out how the transformation is done, and to somehow specify that to the translator. Second point you made, which was why break this up rather than doing one flat service type. The one thing that you need to express in the whole service instance name is the entire protocol stack as well as the service that you're exporting. And so I guess to me, it's a little easier doing it this way, to use the main service type label. Here it's underscore OIC, but broadband form, for example, defines several of these that help to express the particular binding of COAP that they're talking about, whether it's WebSockets or TLS or I probably don't have them all correct, but.
That's not part of the resource type.
No,
Don't assume there's a correlation between resource type and protocol.
Yeah.
No correlation.
I'm talking about basically translating. Yeah. I'm trying to just say that at the end of the day, if you're trying to, sort of figure out where's the semantic alignment between what core is doing and what DNSSD is doing, we have this notion of services and service types, right? But at the end of the day, you need to be able to sort of express the whole protocol binding in there. A service, in my definition, would be, the endpoint where you can find the listening socket, the IP address, the port, and basically the protocol that you're talking. Where protocol is kind of the entire stack. So there doesn't have to be a one-to-one. There's not a direct correlation, but I'm saying we can take one and translate it into the other. If that helps. If you don't believe me, let's talk about it on the list.
Okay, this may, Tim Wasinski, DNS co-chair.
Hold up, Tim. Barbara was in line.
Oh, sorry, that's right, Barbara. You go first. My bad. Yeah.
So yeah, as Carrie and I have discussed, broadband form does have some use of COAP where it has some registrations and things, and we want to make absolutely sure that those uses are not impacted by anything that the core working group decides to do, and that we don't suddenly have to do something special or that certain weirdness is going to happen. And so I really want to make sure that it's somehow which devices are going to do this special thing that you're doing, and not assume that everything that has registrations in the core registries are going to be doing this.
No, it starts with the device itself is responsible, or the manufacturer of that device is responsible for saying, it wishes to export that information. And then presumably there's a heuristic for how to do the translation from one world to the other.
I just want to make sure that broadband form devices aren't expected to follow that heuristic.
Never set that attribute.
We define the RT values for our devices.
Yes, right. But
We defined our RT, we defined our IF, and we should not have to use this heuristic.
fine. Yep. Don't set the EXP attribute.
Barbara, any more final? Okay. And Tim Wasinski, DNSOP co-chair, I just want to make you all, and you may be aware of this, we have a draft that's finishing up working group last call that Dave Crocker's worked on for the past year or so that addresses underscore labeling in DNS names and actually builds a whole IANA registry. So, and this is going to start filtering through the IETF very soon. So people will want to sort of, and he actually has another one that basically fixes up text records, SRV records, and gives guidance into how these things should be sort of scoped and stuff. And so these are going to be rolled through as BCP, and you're probably aware of that, but I just wanted to make sure that, you know, and this is for Dave, the chair, that if these documents come up, that basically people pay attention to that, right? So, and add the appropriate reference and stuff like that. But there's going to be a whole IANA registry to sort of scope all those out and make sure people are sort of paying attention to that.
Awesome. Does it allow for more choices than just underscore UDP and underscore TCP?
It does. It's yes, and I can point you that stuff. Okay.
So then maybe that would be a way to
exactly
solve the the binding question.
We had to split it up into two different drafts. One fixes the stuff that's out there, and one basically builds the registry and gives guidance moving forward, sort of thing.
So can we just connect afterwards? And you
Yes, I will. Yep.
Super. Thanks.
Just speaking as chair, Kerry's draft is in the core working group.
That's right.
So I'm just going to add work on Tim's plate to have you talk to the core chairs.
Yeah, and if I didn't mention it, it is actually a working group draft there because it was part of RD initially. Well, it started as an individual submission. It got incorporated into the RD draft and then removed just to separate, concerns.
Removed, separated.
Yeah, separated. Yes.
Customer one of the co-chairs. So I think what we are seeing here is just an instance of the slight impedance mismatch between service discovery and resource discovery. And on the DNS side, the idea was to have services that are registered. On the core side, we said, there's such a wide variety of services. We want to provide both registered services, which is of course what the SDOs are going for at the moment. So that's all we are seeing because we're seeing SDO documents. But everybody can make up their own service types, and that's what we have the UI side for. So the fact that there are no SDO documents using the UI form of resource types, that's just an artifact of that they were not made for SDOs. They were made for people who just want to build something. So given that impedance mismatch, it just sounds right for me to say, okay, there may be some resources we just can't map to DNS. And ones that use a resource type that is not registered may belong to that. And the other question is, how do we map, synchronize, whatever these two registries? And we need an answer to that. And the answer also may be guided by the fact that there is an impedance mismatch. So not everything that is registered on the core side may need to be registered on the DNS side as well. So that we don't have to fulfill the requirement that everything translates. And of course, then there's also the X-bit that you can use to control this some more. But if somebody sets the X-bit on something that's not translatable, we still cannot translate it.
Thank you.
I'm going to cut the mic lines after Dave.
Which, no, this is you, Dave.
No, I was going to say Stuart, but go ahead. But please try to keep it short, people. We need to move on.
Yes. Dave sneaks in as the second Dave. Anyway, okay. I have a problem with using RT as a service at all, just in concept. A resource type is a very fine-grained thing. And service discovery should be, I want to find thermostats. I don't want to find the unoccupied holiday set point for low humidity. That just doesn't make sense.
So you don't export everything.
So, yeah, right.
In
So,
this
right.
case,
I knew that. No, I was going to say, so your answer is don't export it. So the question is, what do you export? And so you want to export the concept of a thermostat. And I'm wondering, isn't that more IF related than RT related?
Could be. I mean, this is
I-
maybe
I-
a philosophical point we could take
Right.
to the list.
But I mean, I think that's my point. And so, but I'm also with Dave Taylor is I think if that's what he's saying is let's just register RT as a sub protocol and register IF and be done with it.
Again, I would encourage everyone who's got comments to please bring them to the list because that's where these discussions are really going to be captured.
And to add to that, I think it would be nice to cross-post between the core and DNSSD
Yes.
working groups, so we get people from both working groups commenting on this.
Yes, thanks.
Okay, so Dave Taylor. So when I said that decouple what the protocol is from what the RT is, right? The thing that goes where underscore OIC is, you responded, Carrie, saying that's what you want to be the protocol. So I said, fine, then don't derive it from the RT value.
No, I said that's
right,
one way it could be
But
used.
that's not what I
Now-
got in
now that I
line to
know that
say.
we could potentially replace this label, that could also
So
be the place where it's.
what I got in line back to say was, if you, I'm going to draw an analogy. If you look at where IF equals, you see the part that's in yellowish orange, right? That could also be a URI, right? And yep, you're sticking that into a text record, right? And so the text records are used for filtering after you get the stuff back, right? The client can look through and say, oh yes, I know how to do this. I could do filtering. I could do use of them, whatever it is, right? You'd like to be able to filter them based on the name because that gets rid of all the extra applies. You could do an extra pass after the end that says, I'm only interested in things with IF equals whatever, if you wanted to do that, right? Because that's one of the limitations of DNS, right? And so what I'm saying is you could take the full RT value, even if it's a URI, and stick it into a text record. Now, you lose some efficiency, so you said, how good can you get at filtering by putting it into the name? And that's where your R-temperature comes from. And you start off by saying, oh, but there's some really complex because different organizations have long lengths, so they have different character sets and so on. And what I meant to say is that if you can deal with all that complexity, dealing with URIs too is not that much extra. So when I said it could be something like the R-temperature, you'd like that to be readable, but if you can't, make it be, a hex encoded hash or something else is whatever a good DNS encoding is for getting a short label there, that you may get some collisions, okay? But as long as you can put stuff into a text record, you can do the extra filtering as a second pass. Okay? So as long as you don't care about human readability for these things that are long and weird character sets and URIs and so on, you can get everything that you want as long as the client is allowed to do this extra pass based on the text records and have TXT RT equals whatever.
Yeah, and I'm sure as Stuart would say, the service type was never meant to be human readable. Not necessarily.
Yeah. Stuart Cheshire. The service type was not supposed to be seen by normal end users. It is convenient for it to be mnemonic. So the
In the case of M2M, it's probably one of the things that, will guide the search.
It has some impact on debugging when you're looking in Wireshark and you see all this
Yeah,
gobbledygook and you don't know what it means. The reason I came to the microphone is Dave said earlier, RT has nothing to do with protocol, and there was a bunch of people nodding, and it made me realize that maybe I'm confused about what the resource type is. So maybe mapping resource type to the service type or the subtype isn't the right thing, because at the discovery filtering level, so I'll take an example. I have a thermostat at home that's in the hallway, but maybe I don't want it to be adjusting the temperature based on the hallway. I want it to be using the temperature in the bedroom or somewhere else. So having a way that thermostat can discover on the network, find me the list of things that can report temperature. and I will then use those things to control heating and cooling. That is the semantics of what you want to do by service discovery. And in the example you give that the RT is temperature, it kind of implies that that is things that can report temperature. But if that's not the right intuition, then maybe it's something else. Because Dave was very, did you want to, that's my point.
No,
Take it to the list.
we really should take it to the list. Again, my starting point was the kinds of things that should be exported are really entry points to RESTful APIs, which implies that, you not only start off with a given, with a starting path, but you can discover other links from that starting path that will give you, all the information about that. Anyway, thanks for the conversation.
Thank you, Carrie.
And I emailed you the links to the drafts, and it's also in the minutes.
Thanks.
Yeah, it is.
I am Stuart Cheshire still, if anybody forgot that. Christian Huitema was going to be presenting this. Unfortunately, he had a death in the family. He is attending to that. So I am here standing in for Christian. I hope we also have Daniel Kaiser on the
Yes.
remote participation, because Daniel has been doing some work with Christian on this too. So Daniel, feel free to jump in with comments if you have any. We have 5 documents talking about this. They're listed there. I won't read them out. This started off a while back with an initial solution by Christian and Daniel. And I should start by explaining why we care about this. When Service Discovery started, back in the days of Apple Talk, the fact that you could discover stuff on the network and connect to it at all was kind of remarkable. And back then in the 80s, nobody was really thinking very much about privacy. Laptop computers didn't exist. Certainly phones with Wi-Fi didn't exist. In today's world, that has changed a lot. And the stuff that we did 10, 20 years ago is no longer appropriate. David has been asking every opportunity he gets this week for people who care about privacy to come and participate. So I hope we have some of you guys here, because this is really important. I do not pretend that I know what the answers are. I'm hoping that collectively we can put our heads together and work out ways to solve this. Christian and Daniel started off with a proposal for this that involved exchanging symmetric shared keys pairwise between devices. And it was a good first start. It has some scalability issues when you have large populations. There's a new draft that talks about some of the requirements to try to frame the discussion about what it is that we need to achieve. We have some examples here. There are some scenarios where there is a service that is inherently public. In the business center in the hotel, they have a printer that you can use. That's not a secret. If it were a secret, it wouldn't be very helpful if you didn't know they had that service. The client using that service may not want to disclose the fact that they are making use of that service. And the queries that you broadcast may give some clues about what you're doing. In one of the previous working groups this week, I remember somebody talking about, in fact, it was in HomeNet, talking about not advertising the SSID of their home network because that gives them better privacy. What they may not realize is that if you do that, then your phone then goes around broadcasting the name of the SSID that it's looking for everywhere you go. So within 100 meters of your house, your SSID might be private, but everywhere else on the planet you're going, you're telling everybody the name of your home network. So there's the flip side of privacy is you end up exposing stuff somewhere else if you're not careful. So the fact that the client is looking for a particular type of service may be something we don't want to reveal. One of the examples I gave, in fact, it's not this example, but a similar one is medical devices. There's a growing business in medical devices that talk to an app on your smartphone, and I may not want my phone broadcasting to everybody within range that it's looking for a blood sugar monitor for treating diabetes or some other medical device. The example here is exchanging documents. And in that case, the two parties exchanging the documents or photographs or whatever it is want to discover each other, but they don't want eavesdroppers to know what they're exchanging or what their identities are. Oh, and this is another example similar to the medical device thing. Here we've got a watch and a phone, but the same kind of thing applies, that we don't want the watch broadcasting, I'm looking for Stuart Cheshire's iPhone. At the hackathon this week, I noticed that somebody was running a piece of software called HandyPrint on their Mac, which is a useful bit of software from a few years ago. Before many printers had built-in Ethernet or Wi-Fi, and they connected by USB, this was a bit of software you could run on your Mac, and it would re-export a locally attached printer using IPP. Apple marketing people like to have their own names for things. They call that AirPrint, but under the covers, AirPrint is really just internet standard IPP. And I noticed that this laptop was discovering other printers on the network and re-exporting an AirPrint compatible variant of that, which was a nice service to be offering, but probably not what the person intended. It was kind of depressingly easy for me to figure out who owned that laptop and go and have a word with them and suggest that they turn it off. So, so in today's world, people are much more conscious about not exposing personally identifying information. This is where we don't know what the answers are now, and the purpose of this is to have a discussion. What are the requirements? And maybe they're not the same in different scenarios, but I think when we talk about privacy, it's very easy for us to all have our own notion of what we think needs to be covered by that and what isn't important, and people have different assumptions. We think we're communicating, and in fact, we're not agreeing on as much as we think we are. So what we want to do here is actually get some clear words written down about what are the things that are important, what are the things that are important maybe in some scenarios but not others. So I won't read out the slides here, but you can see here are some of the properties we might want. We have three variants in mind. One is the original proposal of shared symmetric keys. We know that has certain good properties. Its scaling is not great. Another option is for each device to have a private key and share the public key with its peers. We are looking for volunteers interested in exploring that area. That doesn't mean implementing it. That means thinking about the properties and deciding whether we want to propose that or whether we want to rule it out because it's got drawbacks. Another option we can imagine is a single shared group key which is very analogous to what we do with Wi-Fi today. Typically at home, you share the same password with all the devices. For whatever the variants we consider and evaluate, scaling properties are really important because we have many, many devices. I looked recently on my home network and found something like 50 or 60 Wi-Fi devices on my network. Everything from thermostats to garden sprinkler controllers to the pool filter pump controller, the inverters for the solar panels. I'm sure if I bought a washing machine today, it probably comes with Wi-Fi, so it can send me a text message to let me know that the laundry is done. We're going to have many, many devices with a lot of the home automation that's being done with things like the Google Home and the whole Works with Alexa program, the Google Nest, Works with Nest program, and of course Apple HomeKit. We might be seeing not just 50 or 60, but a couple of hundred devices on the network. So we need to keep that in mind. We have people here interested in commercial automation for buildings where you may have thousands of light switches in an office building. So we need to do stuff that scales to at least a couple of thousand. We have a question, Mike.
Mohit, so this is my first time in DNSSD, so
welcome.
I'm one of those who you were looking around who's interested in privacy. I'm trying to read up on some of these drafts. I wonder, like, what do you mean by shared public key? So every device has a key pair and then they share the public key or a hash of a public key printed somehow
the intention on this slide was exactly what you said, which is that the device has a key pair and it shares the public key by some means with the peers around it.
Right, but my question is, if I have this printer that has a key pair and it shares its public key, and I know its public key now, later any new peer who comes and talks to this public key or does a key exchange or anything with that public key, I will still know he's talking to a printer or to that printer in that room. So I could do something like ward driving, like where I know, okay, in this building, these are all the devices, these are their public keys, and anyone who talks to them, I can still take notes. So I'm not sure if this really solves the problem, but I'm very new, so I might be missing many things.
Well, this is why it says volunteers with a question mark, is we're looking for input on these topics. We're not claiming we know the answers. We're not claiming this is, we're not advocating that this is the right way to do it. We're trying to make sure that we've considered all the possibilities.
Chris Wood, Apple, I just wanted to ask a quick clarifying question to your comment or your concern. Are you assuming that in the shared public key case that the public keys are actually sent in the clear to the recipient? So for example, I know your public key and I want to send you a message, I also send the public key in the clear?
So Mohit, you could send them out of band, you could scan a QR code printed, that's fine, but eventually once you have the public key, you would still do a key exchange, a Diffie-Hellman key exchange, and that public key would go in the clear. So you could...
No, I don't see why that's the case. If I know your public keys, your public Diffie-Hellman key share, for example, I can just generate a fresh random Diffie-Hellman key share, do a Diffie-Hellman, and then send you my public ephemeral Diffie-Hellman, which is fresh, and you have no idea that anyone has no idea that I'm sending, a message directed to your public key.
Maybe I'm missing something, but if you have a static public key and you do a key exchange, I can see that some key exchange is happening with that public key.
I believe that is incorrect.
I think the point that Chris is making is there are cryptographic algorithms and protocols you can use that use the shared public key to derive new key material in ways that don't reveal what shared key you used. Only the holder of the private key can make sense of your message, and to anybody else it just looks like random numbers and they don't know where it came from.
Yes, thank you for clarifying that.
I'm good at doing the layman's half understood explanation of crypto.
One more comment. We, in a discussion with Christian and some other people, are actively looking at the shared public key case and considering the very detailed description that he put into the scalability draft that seems to come out on top as the preferred approach if you actually consider that to be the problem or the main thing you want to optimize for, scaling to potentially many different peers. So if anyone is interested in collaborating, I'm sure we'd be happy to work something out.
Oh, was that the last one? Okay.
So, or you can stay up here, Stuart, unless you don't want to. We're really interested in people's opinions. So either on these variants, like it's great to have privacy people and cryptography people here. And on the, maybe let's flip back to the requirements. Does this sound reasonable to people? Are we missing something? Or do we have something that's going to inhibit us that we don't need?
So I'm going to go and sit down since
Yeah,
I'm
that's
not
fine.
really leading this, but I presented it.
All right, thank you for presenting, Stuart.
Hi, this is Dave Robin. I think I've said this in a previous meeting, but this is reasonable. I think this is good. This is great. But what the slides earlier on showed that the black hat was saying, oh, Stuart is exchanging something, or Stuart is talking to David. Something, oh, there you go, taking notes. Stuart is speaking to David. I'm assuming that's a problem that we want to solve. We want to have the black hat not be able to know that Stuart is talking to David. However, unless Stuart and David both have CIA totally locked down phones that only do this and never phone home in any public way and never release any other information that would identify who they are, people are going to know that MAC address is Stuart and the other one is David. Now, they won't know what service they're discovering with the work we're doing here. They won't know what they're trying to discover, what they're trying to say to each other. These are all good problems. But this is not a problem we're going to solve because that blood gas monitor that's embedded in you phones home to the medical manufacturer by URL to see if there's a firmware update. It's just given away what it is. And likewise, my phone is going to contact home.daverobin.com every now and then. Oh my God, now I've given away who I am, even if everything else is locked down. So basically, I'm just saying that your behavior in other things can leak privacy.
So
you can
absolutely agree. And the other, or people who know more about privacy can jump in. But my understanding is privacy is about fixing all these holes. And we in this working group will not fix all of them. But it doesn't mean we should give up because there are other holes. Like my favorite example right now for most web traffic is DNS and SNI. They both leak what you're talking to. Two working groups are completely independently trying to find solutions, and we will only be safe once we have both. But I've heard people say, don't bother on one because we don't have the other. That's just causing a chicken and egg problem.
Right. No, that's not my point at all. I'm supporting this work. I want this work to go forward. It's just slides like this that say, we're trying to solve this problem of saying, I'm going to not know that that phone is owned by David, and I don't know that phone is owned by Stuart. Magically, there's no PII leaking out of either one of them, and they're talking to each other. I don't think that's a problem that this proposal and our work presently solves.
Okay, absolutely true. So then I'm going to scope this discussion is the fact that these devices are doing DNS service discovery should not expose more PII than is already being leaked.
Yes, it shouldn't expose what they're trying to discover, but you can't do this Pollyanna thing where it's completely private and nobody knows it's my phone.
Correct, but
I mean, unless it's completely locked down
or
VPN.
In the scope of DNSSD, we don't want to leak more. Like in the printer
Right.
example, there is nothing we can do in this working group about the fact that someone can see who's talking to that IP address.
Right.
But there's something we can do about it saying, oh, David's like this right now. If you browse on this network, you'll see that David's MacBook Pro is here, and that's what we want to fix.
Yeah, good. I just want to be clear on our goals.
Yep. No, absolutely. Thanks. We needed to clarify that.
Stuart, I just wanted to quickly respond to the point David made. I think we could change some wording to clarify what we're talking about here. Is we're not trying to boil the ocean. We are trying to make sure that we don't do anything that contributes to making the problem worse. So within the context of the discovery, we don't want to be adding information that discloses identity or all of the other things that we talked about here. And then the other very quick point, David was talking about MAC addresses. there is work being done to randomize MAC addresses every 15 minutes. So, and this comes back to the point that you made, this is a team effort by lots of people in different areas to all fix the problems that they're responsible for.
Well, I have to jump in here. Yes, you can randomize the MAC address, but until your Wi-Fi chipset supports 2 MAC addresses, one that is all my stuff that I'm normally doing and one that is this super secret channel that you don't know is on my phone, it's still my phone.
Sarah Dickinson. The comment that I wanted to make was about the methodology you're thinking of using. So the best thing we have in the IETF, at least in the moment, is RFC 6973, which is a document which describes privacy considerations for protocols. And the idea behind that was it was analogous to how we do security analysis for protocols. So I've mentioned this to David, and I'll mention it for the people in the room who might not be aware. We've just got a new proposed research group on privacy enhancements and assessments. And one of the remits of that group will be to look at other protocols coming to the IETF, get involved as early as we can in the review. And currently we're sort of suggesting that we start that document, using that document as the basis for the review. One of the things that's already been pointed out is that's the best we have today, but there's a lot of questions about whether that's actually the right thing moving forward to have. So it's the best starting point we have. One of the things that's helpful with is in defining nomenclature, and it has some really good definition sections on things like anonymity and fingerprinting. And what would be nice is if, when we're looking at DNSSD, we can introduce that nomenclature early and people get used to using it, so we have the best consistent set of understanding of what we mean by privacy and the concepts around it. Because again, I can see some of the language on here which it makes the problem clear, but doesn't necessarily align with some of that terminology. So we could look at that. The other thing is, it also dawns on me in the bigger context that this is a specialization of a much more general problem. And some of the concerns that come out of this could have a much wider scope than just within DNSSD. So I think it's a problem that's of more general interest than just this.
Can you repeat the name of the research group, please?
It's called the PRG, Privacy Enhancements and Assessments Research Group. There's a mailing list set up. We had a first side meeting this week. And so we're looking for people interested in working on work items there related to work in the IETF, but also outside of it. We're very keen for that to be a place to collaborate with open source people who are possibly working on solutions that are not documented or standardized. And that's a real potential source of input to the thinking here. And we also want to link up with academics who are, doing the theory of this and are not connecting with the people like in this room who are interested in actually implementing and deploying it. So that it could be a useful forum for input to this.
Absolutely, I agree. Thank you for bringing this here.
Chris Wood, a quick question for, I guess, the chairs in the group. Is it your expectation, or is it our expectation, that whatever solution we happen to come up with will satisfy all 3 scenarios, or are we going to have potentially multiple depending on your scenario, which kind of feels dirty and not too fond of that, but they could be sufficiently different such that different requirements apply, and you could greatly simplify things depending on one scenario versus another.
Well, speaking for myself mostly, but my assumption would be that we'll have to get into solutions a bit more before we can answer that. If someone comes up with a solution that solves all scenarios and is efficient and makes coffee and everything, then we're done. If it turns out that we have to make hard trade-offs, then we may end up fragmenting. My personal preference would be to have one solution fits all, even if there are some costs. But there are cases where that's not always possible.
Okay, then in the one solution fits all case, going to the requirements, back one, how will we identify what are the mandate? Like, pretty much, I don't think anyone's commented on the actual answer to this question. A lot of these are ideal to have, but a one-size-fits-all solution these might not all be applicable.
That's a good, let's talk about that. What's your opinion?
I want them all, right? I want my cake and I want to eat it too.
I mean, is it your intuition that we can build something that has them all?
I think with the shared public key case, everything except the last is sort of difficult. Maybe the last two, but like this is still very much in flux, and we're talking about it. But yeah, I don't want to sit here and design in real time. So
Don't go away. Are you saying that resistance to DOS attacks is solvable?
no. In fact, that is extremely hard to solve.
Okay.
Yeah.
I would say I want all of these too, but if I had to give up on one, probably the one that's hardest, I think, is the resistance to DOS attacks. And if I could get everything except for that one, I'd be willing to live with it.
To follow up on that, I think many of those solutions right now, particularly when receiving a message or receiving a broadcast message you want to tell, or as the service provider, you want to determine whether or not you should reply, requires a linear amount of work in respect to how many peers you have, which is not great because then you can just easily send them garbage and cause them to overwhelm themselves. But there are, I think David and I, we spoke offline about potential ways to optimize that, to like reduce it from linear to logarithmic, but like then again, a lot of logarithmic work is still a lot of work. So I agree with your point that, yeah, we might be willing to bend on that particular issue, but hopefully not.
Chris, in the interest of that conversation we had earlier, can you send the paper you mentioned to the list?
The PERB paper?
Yeah.
Yes, I will.
Thank you.
Andrew Sullivan, just to follow up on something that Dave said, which I think is what he meant, but I want to make sure. If you're willing to give up resistance to DOS attacks, you mean resistance to DOS attacks on the server rather than resistance to becoming an amplifier in a DOS attack. Because I think the second thing, we've already created several services on the internet that seem to be very good at causing problems. So that would be a bad thing for this to be. Yeah.
I think that was my understanding. Yeah.
To Andrew's question, yes, that's what I meant.
Yeah, the requirement to not be a vector of amplification is a requirement of every IETF protocol, in my understanding. So that is a hard requirement that is just absolutely non-negotiable. I completely agree.
And Bennett here, slightly off topic, but before you move on to the next item, has the blue sheet gone around? Because I didn't see it.
Yes, they have. They've gone in both directions. Can someone wave? Oh, they're back there. Thank you.
And the other one is where?
There. Okay.
Raise your hand if you haven't signed it. All right, please pass them around. Thank you for that.
Can I ask one more quick question?
No, please.
With respect to the MAC address randomization thing that came up earlier, unfortunately, I just saw the person who was at the mic step out of the room, so this was not timed intentionally. You were saying that you want to scope the problem to such that you don't want the solution to reveal any new privacy preserve PII effectively. I, of course, agree. That's like a perfectly fine approach to take with this. Does that mean it is out of scope or would be considered out of scope to talk about things you could also do to help preserve PII? Say, for example, you did have the two, radio with two interfaces and you could have two MAC addresses and you wanted to do the thing you did. Would discussing solutions or purchase techniques, insert your favorite word here, that make use of that and use this privacy preserving discovery solution be in scope or not?
I think leveraging this from work would be in scope. We would have to define the scope clearly because I get that becomes a blurry line. An example I've heard from someone is, given that this private discovery is going to involve some key exchange, you could use these keys to bootstrap some other things. That could be in scope as well.
Okay.
But I agree that that's blurry, and I put down an action item that, as a working group, we need to clarify our scope more.
Okay, yeah, so just to echo back my understanding, we can admit or declare victory, effectively, if we get a solution that solves this discovery problem without revealing any new PII. Doesn't mean we shouldn't stop there. We should potentially offer additional, best practice advice, how to further reduce the amount of information that's leaked, potentially by doing MAC address randomization or what have you. Correct? Yes? No?
Yes.
Okay, cool.
All right. Does anyone else have points they want to raise on the topic of privacy before we move on? All right.
How many people have read the drafts? There's many of them. Did you ask that question earlier? Did I miss it?
No, that's a good question.
Okay.
Yes, thanks. Yeah, who has read at least
Can you
one
go
of
back to the list? I think there's a list, right?
Yeah.
Okay,
Yes.
so maybe you can march through the list. Then.
Yeah. Who has read at least one version of one of these drafts? All right. Cool. Who has read all of them? All right. Yeah. No. And I think, and that's on us chairs. It's become kind of complicated to follow along because we have a lot of drafts. So I think we'll try to take an action item to clarify when someone coming into this room saying, I want to see what they're doing for privacy, what do I start reading? Thanks for that, Chris. So we're going to talk about the charter soon, but hold on, Tom. I'm going to do a few things before you come up. Quick question. This came up at the working group chair meeting yesterday, yesterday. They're discussing using GitHub for working groups, which some working groups, most notably HTTP, TLS, and Quick, have been doing pretty successfully in my mind. And I would like to experiment with that in DNS service discovery. So this is mostly a question for our document authors. One of the concerns I've had is I've noticed that several of you use GitHub to collaborate between each other because you're not necessarily in the same time zone, and I think that's great. But I think that would, be a great way to help new people in the working group contribute. Because, like, for example, Thompson was describing how in Quick they have people who come over, look at the draft, and fix typos for them, or just raise an issue and say, have you thought of this? And it's a lot smaller barrier to entry than like emailing a list that you have to join is. Another problem that I've seen is these GitHub repositories that the others have don't have contribution guidelines or mention of the note well, which could cause some IPR problems if someone were to propose an idea there. So the ISG has actually built a framework for us to build these working group repositories that has been reviewed by our lawyers. So it clearly states the note well and other things before people can contribute. And I think that's a pretty strong requirement that we want to make sure the IETF IPR policy is clear to everyone. Go ahead, Tim.
Tim Wyszynski, DNS Op co-chair. We are using GitHub mostly with the chairs to sort of collaborate as well, but we do have lots of drafts. What I've noticed is we do have some documents in our sort of organization, but when I see collaborations, let's say Stuart and Ted are working on something, they may want to work on something before they push it to have other people do it, especially with stateful operations. You guys had a lot of changes, but you weren't ready to share it with the world, which I understand, until you all had sort of, blessed it all, is probably the right way to say it. So there's probably some good path forward on how to do that where you guys can work without us sort of, meddling in your process.
Stuart Cheshire, from my point of view, this seems like a really easy question. I can't see any reason not to do it. Right now, I have some repositories under my name in GitHub. We have some under Ted's name. It's all pretty ad hoc. So this would be the same way of working in a different context. Just to address Tim's point, I don't really care if anybody looks at interim versions. And in fact, we have had that with the session signaling and the push notifications. Some people we're working with at Cisco will actually email us with feedback on a version that we haven't submitted yet. And that kind of took me by surprise a couple of times. But if they're willing to read those unpolished interim versions and comment on them, I have no problem with that.
Yeah, I mean, Ted Lemon, just to kind of agree with Stuart. There's never any intent that those repositories were intended to be private. It's just, we didn't have a rubric to put them under, and also since they haven't been adopted yet, there's that. But
Oh,
but
absolutely.
we're happy to
I
use-
never felt they were private. I just felt sometimes when you're sort of hashing something out, between people, you want to make sure you get your brain sort of aligned before people get, and I have the same problem in my working environment. But, and I don't, as a chair, I've never felt to be heavy-handed, like saying you must move your repo into here. I feel like people have the right to do what they want kind of thing, right? And so I guide by light touch.
I think there's a hierarchy here. An RFC is finished. A submitted internet draft is intended to be readable, but maybe not the final word on any given topic. A working copy that you haven't submitted yet may still be full of typos and who knows what mistakes. But as I said before, if somebody wants to spend the time to read that, I don't mind. And if it really is something that Ted and I are actually not, we're not agreed on, or we don't feel is ready to share, then I think that's the kind of thing we wouldn't check it in at all until we'd had some private discussion and come to agreement.
Or it would be a good use of the GitHub issue tracker when you both lay out arguments, and then anyone can jump in and say, well, have you thought about this?
The terminology BizDraft and DNSOP, which is now standards track and is past working group last call, that's how they addressed every issue, was they opened up stuff in the GitHub issue tracker. And then Paul Hoffman basically and Andrew went through them point by point and addressed them that way. And yes, that is a great way to do that. So So, and how I do it is I give everybody admin access. So it's like with great, tools come great responsibility. So I trust my fellow IETFers to do the right thing, right? So if you guys want access, you guys can have access and do whatever you want. So there you go.
Well, thanks. I agree. I think this would be by no means a requirement from the chairs. It would be work for us to set this up, and then we would offer it to the draft authors, and then kind of see where it goes. There are also open questions. Some working groups encourage people to have the discussions on the list. Some encourage them to have them on the GitHub. I think we can start with one of the drafts and then go from there. So please, if you're excited about this, reach out to us offline and we'll pick a draft and see how it works.
Just for the sake of completeness, I want to ask, is there anybody who doesn't think we should do this?
Thank you.
All right, thanks. Moving on. We discussed this a little bit in London. Our current charter dates back, I don't remember, I had it written down, I think 5 years or more. And the working group has done or broadened its scope since then. So we were thinking with Tim Schoen back then, but now with the next year as well, that perhaps we will need to refresh this. So what I was thinking is I'm going to I wrote a little summary of our current charter because reading the whole thing would take too long. And then Tom Pusateri offered to give us a presentation of his thoughts on this. So our current charter starts, even this summary is way too long for a slide, by giving the background of how DNSSD really started with MDNS, and our main goal was to allow new use cases, mostly focused on unicast. And so we want to build a new scalable solution, but that is still backwards compatible, and look at all the implications there, be that it's security or interactions with other existing protocols. We have a list of networks or scenarios that we care about. Like, for example, mesh networks is one where multicast doesn't work well, and a lot of other ones, and what we want to do in these networks. So this is our current charter. Tom, do you want to come up and give your thoughts?
Yeah, so I think as we've been going for 5 years, the goalposts have kind of moved on us. As you can see, this quote from Ted's draft on the relay, and from another draft about multicast and Wi-Fi. It just isn't working well, and everyone is coming up with solutions to not use multicast. So I think that it would be wise for us to do the same thing, and going forward, that we should be unicast, really concentrate on unicast only, or at least unicast first, and consider MDNS to be legacy. And I think this will change the way that we move forward and we think about things. And so I wanted to talk about it because as we come up with new charter items, I think it's important. Another issue is the whole idea of domain. We search for things based on the domain we're in. And when we have a phone that's wandering around and it's moving between cellular and Wi-Fi, what domain are you in? But maybe you're on a campus and you're walking around the campus and you get Wi-Fi sometimes and you don't get Wi-Fi sometimes. And you switch back and forth between LTE and Wi-Fi, but you're still on campus and you still think that I should be able to get to the services on this campus. So I think sometimes the location is more important than the DHCP domain that you receive. And so things that are location aware, like Bluetooth proximity sensors, or maybe just a pre-established association that you have with a organization, like you're a part of a university, you're part of a company, those the domains from those become more important, and the one you get from DHCP becomes less important. Another example is you want to tether your laptop to your phone. And so you don't want everybody to tether their laptops to your phone. You just want to be able to tether your laptop to your phone. So you need the services that are being offered have to be authorized. They have to be independent, not for everybody, but for personal consumption. And services are personal. And that's the transition that I think we should focus on as well, that we're not advertising services to everybody, and these are all the services that are available, but you may not be able to connect to them. We need to think about the services that are available to you and why are they only available to you. That means they have to be authorized and you have to be authenticated. The attached network that you're on is going to become irrelevant. If I'm traveling, I want to know the services that I can get, and they may be at my home, they may be at my company, they may be on my campus. So, I don't literally mean a .tom Pusateri domain, but I mean what are the services available to me, for me, that I can use now, no matter where I'm at, independent of the location. And if you're on a campus, you have services that are available to faculty members, you have different services that are available to students, different ones for staff or for employees, and then you have guests wandering on campus that you don't want to offer those services to. So these all need to be distinguished. What is available to whom and when and where. If we think about transitioning from multicast services or doing discovery over multicast to doing unicast only, what does that world look like? Well, the discovery proxy that we've just completed still provides a nice sync point for all of those unicast services around different subnets to collect on. So that's still useful. But right now it relies on some domain name that you learn from DHCP or static config, or you're searching, what's on my subnet or something. So we still have to think about the domain name issue. Let's see, the whole cellular problem is one that we have to think about, but that's really the domain name issue as well. I think we need to think about a general framework for authorization. And, some of the problems that Ted's fixing with update are very specific to the kind of constrained environment with batteries a problem. But there may be other issues with update that we want to enhance. So maybe we need to enhance DNS update, do another revision of that so that we can solve some of these problems easier. And that some of this work may be done in this group, some of it may not, but it might be a bigger part of the picture. So right now we're taking all of the MDNS traffic and relaying it up to the discovery proxy through the MDNS relay, but we're carrying the MDNS traffic on. Another way to do that same thing may be to proxy the update. So if we do unicast updates everywhere, but we still have this legacy MDNS traffic, well, we just have a same sort of relay that we, because it's distributed on every network, but instead of sending all the multicast traffic, it just translates it and does the DNS update for us, for those services. If all of the services, and there's scaling issues, to consider with that, you can have multiple update proxies on a network for redundancy. You may update to multiple discovery proxies for redundancy. You could still use the subdomain hierarchy for if you want to make it scale better, but you're going to end up with a lot of services back at the discovery proxy. But I think we can make that scale okay. But if they're all there, then we get some new features. If we know what all the services are, then we can do DNSSEC. We can have NSEC records. We can, it looks like a unicast DNS server. So I'm not sure I'm not trying to design a protocol right now. What I'm trying to do is make us think toward unicast, and maybe that will drive the milestones that we create when we recharter. Maybe the discovery proxy that's collecting all this stuff turns into a normal unicast DNS server, and all we need to do is the update proxy. I'm not sure. I just want to throw out some ideas and get everyone thinking about unicast. So,
thanks, Tom. Tim Wasinski. So I work for this employer called Salesforce, which you guys have never used. But we have a web app, we have phone apps, we have watch apps, I've been working with our service discovery team internally on how to map services basically in the same way versus various levels of authentication. As you go in and out of wireless, how do you deal with this? And it's just hack upon hack, right? So I love a lot of these ideas. And I think it'd be like, I've been sort of beating my head against the wall trying to get them to figure out how do we solve these sort of same problems. So I'm all for this. So.
Thanks, Tim.
Carrie Lynn, I rode shotgun on the chartering effort the first time around. I didn't want to believe it's been 5 years, but I went back through my email and sure enough, time flies when you're having fun. I actually remember the first time that this group met, and it was in a giant hall, and there were so many people that wanted to contribute, but I guess we're down to like the serious folks here now. I wanted to add a couple points. First, I expressed the desire earlier to see M2M service discovery be brought into the fold. It was explicitly not considered as part of the charter the first time around, just because we had more important things to nail down first. We did have placeholders in our initial charter for things like providing solutions over mesh networks. So just an additional point to your cry for concentration on unicast is to make things work over multi-link subnets as well. So let's just not lose that. The second point I wanted to raise was, it seemed to me that we had several requirements that came from the HomeNet group after we chartered. Even though we asked for lots of input, I think one of the things we had in mind initially was that we would provide the service discovery solution for HomeNet. I just want to make sure that we do a very good job this time around of making sure we've captured all their requirements, if we haven't already, solved them, and make sure that they're also part of the new charter.
Thanks.
So Dave Taylor, thank you. I think this was a really good presentation. I want to go back to two distinctions that you made for two usage scenarios. You had one scenario that was on an early slide that was basically, I'm interested in finding things near me, and you talked about the lack of relationship between, say, network topology and physical location, right? That's the one. And then there's a second scenario that you mentioned, which was the services are personal slide, which is I want to find things associated with me regardless of where they are, right? Those are two very different use cases. Find things around me that I may not know about already, like I'm looking for the IETF printer, but I've never been here before, I'm a newcomer, right? Or find things associated with me, which may be in my house or maybe wherever. I think drawing that distinction at the sort of the scenario level is a really good distinction. So I now want to focus on the one that's finding stuff near me, and because this gets into, it's tricky to come up with, if you're going to put stuff into a charter, I like that distinction. Tricky to come up with what the right scope is of that, because it goes outside the IETF and trying to figure out what the right way to do it in the IETF is. And so the finding stuff near me comes into questions about pre-connect discovery. So if I'm going to look for speakers near me, I may be looking for Bluetooth pairing, I may be looking for IP discovery, or I may be looking for something else, right? And so what's the right scope when looking for speakers near me? Because in the IETF, we tend to think about it as a post-connect discovery. I connect to the network, and I look for stuff that's on the network. But I like what you've done in the explanation. I think it gets back to sort of the way that Stuart phrases things about not only we're good at solving the problem right, but we rarely ask, what's the right problem to solve? And we do that when coming up with charters, right? And so we're trying to figure out, do we want to scope discussion to be a post-connect thing? And I think in a previous discussion, Stuart made a suggestion of sort of documenting what the UI assumptions are, right? We don't do UIs, but if you can describe a usage model or something that helps to frame things. And so, part of the problem is we have sort of disjoint UIs, right? If you're discovering speakers in most UIs, you say, the user knows that I'm looking for Bluetooth, and so therefore I go off and I go and look for Bluetooth stuff. But we don't have the user say, I know that I'm going to look for MDNS versus DNS versus, some other protocol or whatever. And so the UIs have sort of tried to abstract that, but not always, right? Sometimes we make them say, oh yeah, you got to look for Bluetooth or whatever. Is that good? But what are the UI assumptions? So I'm saying the near me is actually really tricky to come up with what the right scope is. But I like what you've done so far. I just don't know how to phrase it.
Okay. I'm cutting the mic lines after Philip, but our AD is always welcome to talk.
Yeah, you can't cut him out. This is going to turn out to be the wrong place, but it's always the wrong place. What you have there is a bunch of different ways of discovery. And at the moment, what our definition of discovery is procedural. It is you go off and you pull these records out of the DNS or MDNS or whatever, and these are what they mean. I think that if you're going to, and that's fine if you've got one way of doing things. It's less fine if you've got two. I think that what we need to do is to have an abstract definition of what discovery is, so that people who then come along with a discovery mechanism know what they need to provide in order to plug their piece of idiocy or genius into this thing, and there is a clean API at one end and a clean API at the other, and they can just fit their doodah in there. And I think that that will be something that will be very useful. I've tried to do it myself. I'm not sure that my proposal is the right one, but the reason I did that is that I want to see that abstraction somewhere, because DNS is fine, But, people are now talking about doing DNS over HTTP. They're talking about, and I thought that was a crazy idea at first, until somebody said, oh, well, you open up the web page, you can just squirt down all the DNS data for all the links, and oh, now I've got a censorship bypass protocol. So I'd like to see something like that.
So thanks. And you said you had a proposal. Could you bring it to the list? Because I would like to see this conversation happen.
Terry Manderson, responsible ED. Thank you for bringing forward your thoughts. It's fantastic, and it's fantastic to see some mature discussion in the IETF on charters. If I can beg the chairs to make sure that this does go to the list for more discussion, and additionally set aside time, probably a little bit more time than what we have today, to discuss this, modulo my concern that we still have charter items to complete.
Absolutely. Thanks, Terry. So thank you, Tom. So in terms of process for this moving forward, we're going to need volunteers to write charter items. Is anyone in the room willing to help? Yes. Wait, hold your hands up so Barbara can sign you up.
Usual suspects.
And our goal would be to have you provide this text on the list, make a lot of progress on the list, and then probably square away more time for this in Bangkok. Yeah.
Yep. And Tim, the other Tim. Yeah.
All right.
Yeah, Tim number 2. Yeah, that's true.
All right. Very quick conclusion, if I manage to. There we go. So, just as a quick wrap up of what we did today. We went over the status for the Discovery Proxy, so we'll have more activity on push in the next few weeks. We're almost done. We went over MDNS Relay. We now have an implementation in the Shepherd. We just need more reviews, so please review that document. Service registration, we have a lot of interest and running code, which is great. So hopefully working group adoption will happen very soon unless someone opposes that and should scream now and loudly. We might have a new document in this working group for eDNS zero release. Sounds intriguing. Interaction with core, we had a lively conversation on what the actual meat of the mapping should be. So I look forward to see the conversation continue on the list. Please cross-post the core and DNSSD because we want input for both communities. On the privacy discussion, it looks like, so that was great, but we need to clarify our scope a little bit better. We need to look into the RC 6973 privacy consideration and get early review from PRG, the new privacy research group. The chairs need to make it clear for new people what drafts they need to read. We're going to experiment with GitHub because it sounded like we had support. If anyone doesn't like the idea, please bring it to the list. Otherwise, we'll pick a draft and experiment there. And it looks like we have new focus areas for a recharter. Thanks again, Tom. And we'll look forward to people providing text on the mailing list and making progress on this so we can ask the question of having the actual test ready in Bangkok. That concludes our meeting of DNSSD. Thanks everyone for coming and see you in Bangkok.
Thanks. And if you haven't filled out the blue sheets, they're right up here. But I think everybody signed them.
Not the what? Not the FUSD working group. I suppose so, yeah.
No, I mean, we've made that decision up front. I mean, we're DNS-based service discovery. End of story. If you want to do it some other way, start your own working group, knock yourself out.
I'm not signing it, you know that.